My name is Jeff Mielef, and I'm a Principal Program Manager with the Office 365 engineering team, and work on a number of areas, including Exchange performance and scalability. And I'll let my co-presenters introduce themselves as well.
Hey everybody, my name is Nasir Ali. I'm a Principal Escalation Engineer with Exchange Support.
Hi everybody, I'm Justin Turner. I'm a Support Escalation Engineer with CSS.
Hi everybody, I'm Bob Samer. I'm a Principal PM Lead on the Office 365 Exchange Online service.
All right, so let's briefly go over what we're going to talk about today, just so we're all on the same page in terms of the goals of the session. So we're going to spend a little bit of time talking about prevention of performance issues, essentially the sort of high-level guidance of how you go into the design process, the architecture process, and do the right things to ensure that at the end of the day, you're not going to actually have to end up on the phone with a couple of these guys, helping to diagnose problems and potentially fix a very nasty production issue. We're going to talk about some tools and troubleshooting methods that we use internally to diagnose these issues, with the idea that some of those techniques may be helpful for you, maybe things that you can either directly take home and try and do on your own, or at least understand a little bit better about how we diagnose issues, so that as you're trying to troubleshoot things in your own deployments, you can potentially use that as input and help you think through how you might solve those problems. And we'll also be spending a little bit of time talking about how we do this in Exchange Online. Bob's going to walk through how we detect and resolve performance issues in Exchange Online, and how that helps on-premises customers. How many of you are actually in the cloud today, Office 365, Exchange Online? Okay. How many of you have an on-premises deployment? All right, so that's about the audience mix that we were expecting. This is going to be fairly geared towards an on-premises audience, but we certainly have some content for those of you Exchange Online users as well. So I'm going to kick it off with the best practices, and then we'll move into the different sections. And we're going to have a number of tools and other resources that we'll be pointing you to throughout the session. The deck is available online. You'll be able to get these links directly, so don't feel like you need to take pictures of the deck or anything like that. So, preventing issues. How do we avoid actually getting into scenarios where we have performance problems with Exchange? I've been doing performance and scalability for the Exchange Server product for 17 years. We actually have, we've done this is going to sound like a pat on the back, but we actually have done a really, really good job over the years of producing deployment guidance, scalability guidance, performance guidance for Exchange, and to the point that we typically have some kind of fun conversations with other server workloads within the company who really want to emulate us. And this particular example that I have up on screen right now is a good example of that. We have a role requirements calculator for the Exchange product that takes as input, well, potentially really a lot of inputs, but can actually be fairly simple, where it's looking at things like the message rate that you expect to handle within your deployment, number of users, number of sites, the type of hardware you intend to operate with, and it'll turn that into a recommendation and an estimate of essentially how much load is going to run on those servers. So CPU requirements, memory requirements, it'll turn that into details about domain controller requirements. You'll be able to look at network bandwidth requirements for log replication, all these things that you need in order to go through a proper sizing process for Exchange. This is a free tool. It's really easy to use. It can get complex, but you can also keep it simple if you want to, and you should certainly do that if you can. There's really no good reason not to use this. Anyone here not familiar with the Exchange role requirements calculator before today? Okay, a couple. All right. aka.msexcalc is a great short URL to get there. You should absolutely go download it if you're not familiar. And we do constantly update it. It was updated on Tuesday of this week to reflect some new guidance that I'll talk about in a moment. Scalability is a big deal for Exchange. It's a big deal for any server product that's going to be business critical, right? It's a big deal for any server product that's going to be deployed on big hardware. And Exchange is typically deployed on bigger hardware than some of your smaller line of business applications. So for the Exchange 2013 and 2016 products, we do scalability a little bit differently than we have in the past. We used to have big labs filled with big machines. We had strong partnerships with server hardware vendors, and we had gigantic mainframe-sized servers in these labs where we would test Exchange and try and figure out the breaking point. We don't really do that anymore. Frankly, there's a sort of a diminishing value of that over time. Because as we have focused more and more on the high availability aspects of the product and the benefits to deploying on smaller servers that sort of become this redundant array of inexpensive servers that are designed with the idea that they will fail and that the product architecture will allow them to fail and respond appropriately, it becomes much more cost-effective to use smaller hardware, still, decent server hardware, but smaller hardware than the top-range scale-up machines for Exchange deployments. So within Exchange Online, we tend to focus on what we would consider mid-range commodity servers, typically 2U class machines, and that gives you an idea of generally the number of processor sockets and drives that'll fit in these machines, just based on the space available. But they're typically 2 processor socket, and you'll find 12-ish large form factor spinning drives in them. That tends to mean that that's going to be our target type of hardware for Exchange 2013 and 2016, because that's what we are most familiar with. That's what's going to show up in the Exchange preferred architecture. It's an attempt to be a guideline for an on-premises deployment that emulates our own internal deployment as much as possible. And that's really what we recommend for the best experience with the product. We really want you to consider scale out, not scale up. Designing your deployments for these smaller machines, more of them, with the idea that you can handle failures a lot better with these machines. And ideally, you're also going to have a cheaper deployment over time. Ideally, these machines are going to be much more cost efficient for you when you compare that to a scale-up deployment. So we don't push the top end like we used to, and we don't want you to either. There's a link on this page, on this slide, to a blog article that goes into quite a bit more detail about this, if you want to dig in. A couple of quick updates around scalability, specifically for Exchange 2016, and actually the last one applies to 2013 as well. So for 2016, for those of you that didn't notice the blog post on Tuesday or hear this in a number of sessions this week, we've changed our updated maximum memory guidance for Exchange 2016. Up until Tuesday, that maximum memory guidance was 96 gigs of RAM, because the initial hardware SKU that we deployed for that equivalent code base in Exchange Online had a memory size of 96 gigs. We've updated that to 192 gigs. A couple of reasons for that. We have much more runtime on that particular newer hardware SKU in Exchange Online that has 192 gigs of memory. That allows us to have some comfort that our code will run effectively and without issue at that memory size. We've also certainly heard feedback that it's increasingly harder to actually configure modern servers with 96 gigs of RAM. And so that leads you down various deployment paths and architectural paths that may not be the best options. So hopefully this helps to resolve some of that, and it'll be a good thing. It does not impact existing guidance for Exchange 2013. At this point, we're not changing guidance for 2013. The code that we're running in Exchange Online is much closer to the 2016 product. And so when we think about what we're comfortable changing with the knowledge of what's running in the service, 2016 is where we're going to target this guidance change. We're also not changing the processor core count guidance. We totally understand that that is an area where you would like us to increase, and we're actively working on figuring out how we can do that safely. The second item I want to call out here, in general, we don't call out specific guidance. Oh, that's interesting. I just lost my screen. It's okay over there. In general, we don't call out specific guidance for particular hardware platforms from our hardware partners. But it is worth calling out that there is a BIOS default that HPE ProLiant Gen 9 servers ship with. And that BIOS setting is designed to essentially optimize the hardware to be able to take advantage of scale-up workloads and be able to take full advantage of all the platform features on that hardware. Unfortunately, there's a side effect for workloads that don't really fall into that bucket. One of those would be Exchange. And out of the box, Gen 9 servers with their default BIOS setting for NUMA group size optimization will actually see half of the physical processor cores that are available on the box. So you won't actually be able to take advantage of all the processor cores that you've purchased. So if you happen to be deploying this hardware, just be aware of this. There's a link to an HP advisory out there where you can get some more information, but it's a very simple tweak to just go change this in the BIOS and resolve this. The perf health checker script that we'll be talking about later today also looks for this issue and will warn if it sees this as a problem. Not an issue for Gen 10 servers, Gen 10 ProLiant servers from HPE. They've switched the default back to being flat as the default setting. So just be aware of that. All right, I'm going to quickly go through a couple of high-level best practice slides, and then we'll move into the troubleshooting content. So virtualization. I've also seen some comments on Twitter this week that the Exchange team is trying to push physical deployment more than virtualization all of a sudden again. Let's be clear, that's absolutely not the message we're trying to drive home. We absolutely support virtualization, support it as a strong choice for deployment of Exchange, but again, it's a choice. It's something you can do if it makes sense for your business. We published the preferred architecture as some guidance for what we see as our vision of the best architected deployment for Exchange. It's not going to apply to everyone, and certainly all aspects of it are likely to not apply to anyone. But as close as you can get to that architecture, the better. And if you need to virtualize, there are ways where you can apply that architecture to a virtual deployment and be better off in the long run. From a performance perspective, do not overcommit resources. That's really the only thing we have to say around virtualization. All the hypervisor platforms allow you to overcommit things like memory and CPU. Just don't do it. Exchange does not perform well if you do that. It doesn't matter if you are only running a single Exchange server on the box and you're allowing the hypervisor to play around with resources under the covers. It does not work well with Exchange and is a very, very, very common reason that we see performance escalations from our customers. This is in line with guidance from our partners in the hypervisor space. If you're a VMware customer, go take a look at the great guidance that VMware has around how to properly deploy the Exchange server product on VMware. They will tell you the same thing. Don't overcommit, right? So follow their guidance, follow our guidance. It's nice that generally it happens to be the same. Hyper-threading is absolutely okay for virtualization. What I mean by that is you can absolutely turn hyper-threading on at the physical layer because the issues that lead us to encourage customers to not use hyper-threading for physical deployments don't exist in that world. And we have some published blog articles that go into more detail on that, which I would refer you to rather than spending time here. Just be aware it's okay in this space. But again, never oversubscribe. From a sizing perspective, size for physical, and essentially the best way to think about this is within the Exchange role requirements calculator, there is a yes and no option for virtualization. If you pick yes, we're going to add some additional CPU overhead to manage those hypervisor requirements. I got it. It's okay. And that will allow the hypervisor to have enough resources to work. So a couple of slides just to drive home a really key point of once you go through the deployment process, you actually need to continue to think about performance and scalability at runtime within your operational processes. And specifically what you need to think about is balance. We run into a lot of issues with customer deployments where things are not balanced in some way, resulting in the deployment tipping over if something unexpected happens, or running into unforeseen limits balance is really key, and there are multiple places in an Exchange deployment where it matters. So at the CAS layer, making sure that wherever possible, you're actually balancing incoming requests to your CAS servers such that things are spread out fairly evenly is extremely important. Right? If you lose a CAS server behind a load balancer, you want to make sure that the impact of losing that CAS server is going to be as minimal as possible. And that means that when you fail over those requests or fail over that load to the remaining CAS servers, there'll be fewer requests to spread around, as opposed to having a bunch of potentially long-lived connections for RPC over HTTP, as an example, that were tied tightly to a subset of your CAS servers. If one of those fails, the impact of that is going to be much greater, as opposed to trying to spread out that load evenly. There's a performance counter on screen that's a good one to monitor. You want that to be as even as possible across those CAS servers or those multi-role servers. Within a DAG, we always want to have a good equal distribution of active database copies. We ship the product with a script that helps you do this. You can actually automate this. You can run that script out of Task Scheduler and just let this happen behind the scenes. Let Exchange figure out when it's safe to rebalance things for you. It's a great best practice. You can also ensure that when you perform failovers or switchovers, I should say, that things remain in balance as much as possible, and the maximum preferred active database parameters can help with that to try and avoid individual servers from getting overloaded as a result of that activity. The database mounted performance counter on this screen, also good one to monitor, good one to try and keep as equal as possible across all the servers in a DAG. Obviously, if those databases are loaded differently in terms of the mailboxes within them, then what I just said may not actually matter all that much. You want to actually have the workload that's hitting those databases also be as balanced as possible between databases. And that may mean that you have to move users back and forth between those databases in order to optimize. If you have super heavy users and super light users, you probably want to actually have a pretty good mix of all of those user types spread out across your databases. You don't ideally want to have all of your super heavy users, whether that's your execs or your users with certain types of mobile devices that tend to hit the database more. You don't want to isolate those onto a subset of your databases with the idea that maybe you're going to be able to provide a better level of service. The best way to deal with that, spread them all out, keep things as equal as possible so that through this process of balance, you can get the best utilization of your hardware and also respond to failure events in the best way possible. Within mailboxes, important to call out here that, as we kind of go high level down, item counts, folder counts, these types of things have become less of a problem over the years. They still can be an issue for certain client types. Exchange Online actually has some limits in place by default for new tenants when you create new tenants that attempt to sort of shape mailboxes in a better way than just allowing anyone to do anything. Those limits are actually published. I've got a link to them here. And for on-premises customers, we actually recommend, wherever possible, taking those limits and applying them to your on-premises deployments as well. Out of the box in an on-prem deployment, we don't enable those defaults, but it's a great idea to enable them and then have an exception process if you have users or applications that need to exceed them. So with that, a couple of really critical points, then we'll hand it off for troubleshooting. Stay up to date on Exchange and .NET. There's constantly new performance fixes that we are shipping to you as part of cumulative updates. Additionally, Exchange is heavily dependent on the .NET framework, particularly when it comes to performance. Bob's likely going to go into some detail about that a little bit later. You need to stay up to date on the latest supported .NET framework for whatever Exchange release you're on, and we'll keep you up to date with that on the Exchange team blog. We made some CPU consumption increases in Exchange 2016 relative to 2013. Some blog article up there that will provide you with some detail about that. Just be aware of that if you're moving to 2016 currently. We have some published scalability guidance that I mentioned earlier that defines why we have the limits in place that we do today, how to understand those, and why to avoid going over them. Use the calculator, mentioned that already, won't go into that again. We have some performance thresholds published on TechNet if you want to create some monitoring within your own deployments to understand when those thresholds might be exceeded. Those are great starting points to understand when things are healthy. And I mentioned the perf health checker script already. This is a script that our support team has put together that does a great job of running through a deployment, looking for all the common things that we see that are typically dealt with at the start of a troubleshooting session with Microsoft support. You can download this yourself. It's very straightforward in terms of its recommendations, and it's a good thing to do proactively across your deployment. Okay? Proper sizing, absolutely critical to remain healthy. All right, Nasser.
Thanks, Jeff, for the great overview of what are the things that you need to do before you deploy your Exchange servers. But what happens once you are deployed the Exchange server? It's a continuous struggle. A lot of issues that comes to us are generally very common issues that we have seen across. And I will go over the list of the issues that we have seen. Number one issues is not getting up to date on the cumulative updates. Anybody knows what is the cumulative update that we have today, supported cumulative update? CU6 and CU7. And part of the reason is that, as we talked about, is that a lot of those cumulative updates have fixes that are coming from the Exchange Online, as well as from other customers that have seen the performance issue. So it is very critical that you have always on the N or N-1 versions of your cumulative update. So that's one of the things that we have seen. .NET framework versions, again, keep it on the supported version of .NET Framework, and the one that we have right now is 4.6.2. This is one of the strange ones. Power management, it seems to be when people are deployed their servers, for some reason, some of them may have default setting of saving mode or making the earth green or planet green. And it may not help with the Exchange, actually. That's the only place where it's not going to help, because power management play tricks on your servers, in terms of, especially during the performance pieces of it. So I will show you what are the things that you need to look into it. And then, again, sizing and load distribution that Jeff talked about or touched briefly on this one. The other issues that we have seen is, again, scale-up hardware. Customer tends to buy big machines with a large number of cores. Good thing is that I don't have to bug Jeff if customers are using 192 gig of memory anymore, because it's supported now. So that's a good one. And the last one is the AD performance. These are some of the things that we have just in here that we'll cover in terms of what are the things that you can see on the AD performance. The idea here is that we'll give you the tools and techniques that you can use on your own to detect those performance issues and maybe fix some of those by yourself. So .NET Framework version, we talked about this one earlier. Notice that 4.6.2 is the latest supported version, and then there's a hyperlink here that tells you what is the support for latest .NET Framework version looks like. 4.7 is out, but we have not supported it yet. But as the new version comes in, there will be more information that gonna put out on the Exchange team blog that will talk about what are the versions supported. So make sure that you have, as you upgrade to the CUs, make sure that you are upgrading your .NET Framework. Some of the CUs require you to basically, as a prerequisite, to update the .NET Framework. So there will be those things comes in as well. Power management. So I'm just going to go here and show you the screen. So this is what it looks like when you have a power management, which kind of going back and forth. Generally, if the power management is disabled, you should always see it's 100%, and not see the cycles in between where it's going back and forth between 55 and 100 and things like that. What it does is that it basically throttles the CPU and the NIC, and that's, of course, are the two things that the Exchange uses quite often. Your network bandwidth and your CPU. So that will cause performance issue, that you see, and it's really easy to fix. You basically looked into this particular counter that is highlighted there, and to make sure that the frequency is showing correctly to you. And you can also look into some of the places to see what is set it up. So you can see here that in this particular screen, it is set up for high performance. Make sure that it is set up for high performance. All right. So most of the troubleshooting sizing issues that we have come across is generally have a CPU bound. Memory was issues on some areas, but generally it is a CPU bound. And what we generally see is high CPUs. So customer will call in, they'd say, okay, well, either my customers or my clients cannot connect to the Exchange. Maybe they're getting the prompts, login prompts and things like that. Or sometimes they will say that, okay, everything is working fine. We don't see any issues, but we see high performance, high CPU utilization or certain processes. These processes could be your W3WP process, could be some other processes that Exchange use. So those how it comes in. And a lot of time, what happened is that when the deployment is done, it maybe have done for 1,000 users, and then migration happened, and you now have 1,500 users on there. Maybe it was done without any devices in mind, and now each user has 3 devices, mobile devices coming in, connecting to it, right? So a lot of those load comes into the play after deployment. So it is ideally important for you to check what is your existing deployment looks like, how much load you have on these servers. And there is a information on there. One of the things that people talk about is generally with the high memory issues was, can we enable garbage collection? And how many of you know what this garbage collection looks like? Not the regular garbage collection, but the server garbage collection. Okay, I can go into some of the details, but this is really a garbage collection is basically a way for Exchange or any managed application to basically compact memory and utilize the memory and things like that. And Exchange is actually built for workstation garbage collection. And I can give you more detail, but I think it's 2 things that you need to monitor here when you think that there may be something to do with your memory. Look for your memory allocated bytes and look for the time in GC. Anytime if it is more than 10%, then you are having issues with your processes because if it is spending more time in garbage collection, then it is spending less time processing your user applications, processing your users' responses and things like that. So you will see performance issue when you start seeing the GC. Normally, it will come up in connectivity issues and the slow, mail flow and those type of things. We generally don't recommend changing anything, only support, and we only recommend this after contacting Jeff and the engineering team to see under this condition, should we go ahead and change the garbage collection. So it is not something that we recommend, only we do it as a workaround for some of the highly, like high memory machines and things like that, but it's not generally recommended. And the reason is fairly simple. It will increase your process footprint size. So you generally see your replay service maybe taking 15 gig of memory. After you change these settings, it will start using way more memory, and that's something that we don't want to do, Okay, so it's best, it should not be. So how many of you have seen the health script? Have you used the health script? So best practice I will suggest is that, every time a new CU comes in or anything change, just run the health script, because that is part of the troubleshooting that we do as well. This is first thing that we do to make sure that some of the common things that we have seen across are not actually impacting you. So run the health script and make sure that. I have a screen demo of this one here, this is a screenshot. The health script is actually moved to the GitHub. So you can go to the GitHub, actually download the source code, and make changes. If you think that there's something specific to your environment, you can make changes as well. You can run it across all of your organization and things like that. And generally, it gets updated every time a new CU is released. So there should be a new update of this script by my friend, David Paulson. He generally owns this script, so he will update every time a CU comes in, and he will basically make the changes based on that. So you can get these stuff, and notice that some of the information comes out in red, basically indicating to you that this is something that you need to look into, which is basically the .NET Framework version and some of the other things. Can you hold the question till the end so we can go through the content and so we can do that? Thank you. All right, so one of the things that I wanted to do here is that once we cover some of the things related to, okay, well, now you have a deployment and you are troubleshooting a performance issue. What happened when you send all of this data to Microsoft? A lot of time we collect a lot of data actually, and some of the customer question basically why we need to collect all of this data. How does it help you to find the information? And what I want to show you is that a case study of of a situation which a customer encounter and the data that we collect and actually what we did with that particular piece of data. So I will want to show you some of the tools with that set of data and kind of, go you through, help you or understand the flow of work that we do actually. So in this particular case, customer call in and say, we are having high CPU actually and users really don't having any connectivity issue, but we are concerned that this high CPU will end up in an outage on our site. So we want you to investigate what's going on. So generally it goes through the workflow in terms of, support engineer, then support escalation engineer kind of work and figure out, is this a common issue? Is it a known issue? It is something that is already fixed. And when they come to a point where they say, this looks like a new situation, this is something that needs to be looked upon by a more seasoned engineer, they generally escalate. So when you look into this thing, this is what the information come to us in terms of what the customer was seeing, and what the engineer actually noticed. He noticed that the Exchange Health Manager service, which is basically the one that we use across Exchange for manage availability and all of the other things to find out how healthy Exchange is. So for example, if somebody has a heart problem, and if the machine that detect the heart rate and all this stuff is not working, then you don't know what is the health of your heart looks like. Similarly, when Exchange is an unhealthy state, the Health Manager service is the one that tells you about whether there's a problem, it restart or help manage availability, restart some of the processes and things like that, So what they find out is that, there are performance counters that are missing, that are, and we add the counters, it disappears again. There's things going on that we don't know. Looks like there's some magic spell happen on this particular machine, So we say, okay, let's find out what are the things that we need to collect to understand what the problem is and kind of analyze the data further. So what we did is that we collect the health check script, all of those different things, and PROC1 logs and Watson dumps. These are the data that comes to us, and I will show you what we did with each set of data actually. So the first thing that we look into is event log. That's the place, that application event log, that's generally the troubleshooting starts. That's where we need to find out where there's a problem and what we need to do about that particular piece. And notice that there's an event called 499. So this is basically a Watson event that's telling us there's a process that actually crashing or it's actually having problems. And two things that need to keep in mind is that it's showing you the process that's associated with it, and it shows you the function and the particular binary that has a problem. In this particular case, it is the Microsoft online data center, and I will show you the whole thing in the next slide. So from there we understand that, okay, well, there is something going on with Microsoft Exchange Health Manager worker, and something to do with the counter factory. Most likely has to do with the creating or getting the data from a particular counter, And the exception is system invalid operation exception. So this gives us some idea. And the next thing that we know is that, okay, so there's another event that tells us from the Microsoft Exchange Common, actually a complete stack trace that actually shows us how this thing is actually coming in. And we can see that it is basically happening during the diagnostic when it's trying to collect the performance counters, So here, the two things that are important here. So this gives us good idea in terms of what the problem is. So what we further need to do is that basically there is something which is called every time there's a problem here. Okay, here we go. And I will go into, so while it is getting started, so what we do is that we get the Watson dump and we load into a debugger and kind of look into what the problem is. And generally what happens is that the first thing that we like to see is that what type of exception is happening in this particular case. When you look into this particular case, what we see is that there's a performance exception happen, and this happens in the diagnostic performance counter exit. So basically it is telling us there is something happen in this particular piece. Okay, so these are two things. When we look on a good server, does it come in? Okay, yeah. All right, let me switch here quick. gonna switch to the debugger really quick here. Okay, so this is what a debugger looks like. This is the version that is available on the internet. You can download it. This is basically the vNext version of WinBag or WinDBG. So we take the dump that comes from you, which is collected by a support engineer, and kind of given to us that, okay, during the time of the problem, this is the issue that happened. And you can see that when I look into basically here, I can see that there is a system invalid operation exception happen. If I click on this particular exception, it's going to give me information on what type of exception it is. And you can see that system invalid operation exception category does not exist. And I can do a really quick CLR stack, basically look into what is the managed performance, what is the stack trace looks like. And here, again, I can see that the counter exists. So I know that the counter exists is probably having some issues. And we know that with our managed process, we actually load or depend on the system.diagnostic to show us the performance counters and things like that. Now, one of the things that we do look into is that to figure out which particular counter it is. And if I dump this whole information, I can see that there is poison worker item. This is the particular performance counter that we are trying to load, and it's not there. So when we figure that piece out, then the next thing comes in is to, okay, well, why this particular piece is happening, why it is creating this thing. So that's kind of give us an idea that there's something wrong in this particular area. So what we can do is that we can take the exchange out of this picture completely. At this point, we know that the performance counter is having the problem. Exchange is having the performance counter issue. So what we do is that we say, okay, can we repro this problem without exchange itself? And what I did here is that I have a PowerShell script here, basically one-liner, that's basically going into and looking into a performance counter. Now, in this particular case, I don't have Exchange server here, so I'm just showing you what it looks like when it's a physical disk. So when I go and run this script, it will come back and tell me true, which means it comes back and tell the performance counter exists. When we did with Exchange, what we find out is that on a good server, it is coming back as false. On a server that's having the problem, it's coming back and telling us that it is not good. So here what good looks like on a good server, when we run the same script, and what looks like on a bad server. So from here, we know that it is not Exchange issue. It is something to do with the performance monitor itself, right? Performance monitor or something in the system that is causing the problem. So we start investigating what it looks like, and what we find out is that it's basically there is the proc1 log that we collected. We say, okay, well, there's something going on in this particular scenario, so let's go and load up the performance proc1 log that we have that kind of give us the information on when the process initialized. In this particular case, we look into the perfmon, and when the perfmon get loaded, we actually went to a very specific place in the perfmon. Notice the highlighted DLL, which is netexperf.dll. This is the DLL that's actually get used when we're trying to get the counters. And when we looked into that particular piece, and I'm going to switch back here. And this is what it looks like on, so what we find out is that right after the netexperf.dll got loaded, there is another DLL that got loaded called intercept counters.dll. And we really did not know what intercept counters.dll is. Basically, this is during the investigation we find out. It turns out that intercept counters.dll is get loaded with the system center agent actually. And there's a specific module called application performance monitor that's basically provided by the agent. And what it does is that it kind of sit in between the perf counters and the process. So what happens is that every time you make a call to get the information about a particular performance counter, it get intercepted by this particular DLL and it provide the information. So we say, okay, well, why we need this intercept counter DLL in Exchange? Exchange has all the information needed in there in terms of all the performance monitor counters and things like that. So what turns out to be, and I'll switch back here. So what turns out to be is that, based on this one, we figure out, okay, well, we need to do something. So, okay, here. So we check for the application performance monitoring, and we talk with our internal teams to find out what actually this particular DLL does. And they come back and tell us that there's a known issue with this particular DLL, especially when you are running on a SharePoint server, where it might crash the W3, WP process and things like that. And we explained to them we are kind of having a similar issue in Exchange, where it is crashing our Health Manager service. So basically, the idea was at that point that this looks like a known issue. So what we have to do in this particular case was that we have to go and disable the APM. There was a registry entry that allowed us to disable it. We disable it, and it fixed the problem, basically. So what I'm trying to show you here is that there is different set of tools, which some of them are really public tools, actually. Proc1 is public. The debugger is public. All of those different things that I showed you is actually public tools. But all of those data sets help us to start from a kind of a broad scope and narrow it down to the particular problem and figure out what it is. So at the end of the day, all you find out is that reinstall the SCOM agent with APM disabled, and that will take care of the problem. So that was one of the case studies that I wanted to show you. Now, the other areas that we have seen performance issue is generally with the AD, and I have Justin here that will go over the AD performance issue. Thanks, Justin.
Hi, everybody.
Here, sit down.
So what is an AD performance issue? Have you guys ever had an Active Directory performance problem in your environment before? What did that impact? How did that impact your environment? Exchange was... So when Active Directory, everything has, as Exchange has dependencies on Active Directory, so does a lot of other applications, right? What is a domain controller ultimately responsible for? So yell it out if you have it. Authentication, what else? It's a GC, so it does, it responds to search requests, LDAP search requests. DNS, typically, right? So anything that has the dependencies on auth, Kerberos, LDAP, DNS, or whatever services are running on it, group policy, if AD is down, if it's impacted by a performance problem, then your environment's probably in a world of hurt, right? And so we work a lot of these cases in the Director Services team. And we've come down to basically create a pretty solid workflow I'm going to share with you here that ultimately will help identify the root cause of these issues. So what are the DC side symptoms of an Active Directory performance issue? Typically, what we see is LSASS process is pegged out at 100% CPU, or it's just really high. That's subjective, but when we get over 60, we get 70, 80, 90%, 100% on a domain controller, we're CPU bound. The DC's not going to be responding to those requests. The client-side symptoms, it just depends on what the application is. Here we're talking about an Exchange. So Exchange, very commonly, mails backing up, Outlet clients, keep repeatedly prompting for credentials, just emails down, and so it's typically a critical situation. We got executives on the calls, and we have 50-person bridge calls, and someone's worried about losing their job. It's their worst day when they call us. So we see timeouts, application failures. Sometimes it's just the application receives a slow response to its search request. And so Exchange does a good job of pointing out when we do have a performance problem. And they'll log an event saying, hey, it took longer than 50 milliseconds to respond to this LDAP search. And so then it becomes our job of finding out why did it take so long? So what is the cause of an Active Directory performance issue? And it's typically a handful of things. We'll say excessive or inefficient workloads. And what I mean by that is an excessive workload may be like death by 1,000 cuts, where it's not any one person or one application causing a significant performance issue on the DC. It's just a lot of clients doing the same thing. And over time, we get overloaded with that excessive workload. And then the inefficient workloads is maybe one client is doing an LDAP search that is inefficient, and instead of being able to return the result from memory very quickly, we have to go to disk. And we have to determine what index to use, or maybe there's no index, and so we have to search every single row of the Active Directory database. And if our database isn't cached into memory, that's going to take a very long time. And it's going to take a very long time anyway if we can't use an index. And then there's some other common causes. So scripts that leverage expensive WMI queries, SAM enumeration, SAM enum users in domains, scripts that call will cause, it's just expensive for a DC to do that. Change notification for LDAP, we typically see that in really large Exchange deployments. So we're talking about hundreds or thousands of Exchange servers. Max concurrent API, you guys probably heard of before, yes, no? Yes. So just an authentication bottleneck. And another two common things are null domain authentication and null domain lookups. And what I mean by null domain is instead of a application saying, hey, who is Contoso / Justin? It would say, who is Justin? It doesn't have the domain name in front of the username. And so if we don't have an account with that domain name, or if we don't have an account with that name, we then have to traverse our trusts to search all other domains to find this account. And we'll spend up to 45 seconds per trust. And for customers with lots of trusts, that's going to be a significant amount of time. And so those are hard to spot. You can see the null domain authentication in the netlogon.log. And you can actually control that behavior by enabling a registry value. And I have all the resources and our workflow documented in the references section of our slide. So I'm not going to be able to go into great detail on this, but just know that those resources exist. And null domain lookups is very hard to discover because you only see them if you've enabled something called LSP logging. And so instructions on how to do that, and an example is coming up. So what are the resolutions to these issues? And I'll talk about basically client-side resolutions and the DC-side resolutions. Ideally, we'd want to be able to modify the client or fix this on the client side, then have to do it on the domain controller side. So we do things like modify the app or script. So if it's doing some expensive search, is there a more optimal LDAP search we can do to make that more efficient for a domain controller to process? Sometimes we see clients do 1,000 requests for the exact same thing. Say, hey, who is this user? Who's this user? Who's this user? Repeatedly. And so every time it gets into this function, it just has this lookup, and there's no caching behavior in the script. And so that's the reason for that. So if we can modify those scripts, that's the easiest fix. Of course, stay up to date on your updates, roll-ups. What are DC side fixes? So we need to be able to optimize these inefficient workloads. So we can add an index for the attribute that they're searching on that is causing us to go to disk. Or we can modify our configuration. Maybe change, if it was the case of the LSA lookups, restrict anonymous lookups, we can set a registry value to basically block that behavior so we don't go out our trusts, go through our trusts. Another client-side possible solution, redistribute the clients. Put them in other sites. Make sure the clients are mapped to the proper AD site so it's not going across the WAN and DC's having to respond over a slower network connection. And then finally, of course, increase capacity. Add more DCs, more CPUs, more RAM, whatever. But if you were going to do this last thing, why did you bother even troubleshooting the issue if you're just going to throw money at it. So ideally, you fix your application or your script, or at least you add an index. And one other thing I'll say here on the DC side is we've worked a lot of issues over the last few years, and we've gotten really good at identifying what the root cause of those problems were and identify actually bugs in the server product in ntdsai.dll, and we've done repeated updates to this, and we're pretty solid right now. So are you guys installing your latest cumulative update for Windows Server? It's a good idea because we're rolling those ntdsai, basically the stuff that makes the Active Directory be able to respond more quickly and more efficiently to searches. All those bug fixes we did is rolled into that latest update. So what's our troubleshooting process? Basically, the goal is to be able to map the DC side workloads to the actual client making that request. And so how do we do that? You go into Performance Monitor on the domain controller. You load up. You've seen diagnostic data collector sets there. It's just a simple report that you can run. There's one called Active Directory Diagnostics. You click Start on it. It does a 5-minute data capture. It does a perfmon capture, an ETL capture. It does looks at some registry stuff. And then at the end of the 5 minutes, it creates an HTML report for you that summarizes everything that went on during that 5-minute capture time. And it's very easy to look through. And I have an example here where you'll see where you can spot an issue. And on our Ask DS blog, we've written up scenarios where we've said, hey, this is a scenario where we saw, a slow LDAP searches, and here's how to identify and solve them. 1644 events is a diagnostic logging we can enable on DCs to basically log every LDAP. We could log up to every LDAP search that DC receives. We'll log one event per LDAP search, and it enables us to see what the DC is working on. And so that's the DC side data collection. Once we've looked at this data, we've gone, okay, maybe the issue is this client at this IP address is sending this really expensive search. Now we know a client IP address. We need to be able to identify what's running on the client. So we're mapping that workload to the client. And so we have to go to the client and run task list SVC, netstat, ANOB, and that should be enough to actually get you what you need to see what process is running. But you can also do things like network trace and process monitor. In the case of WMI scripts, you can run enable WMI activity logging, event logging. And the solution, of course, reduce, optimize, distribute, or increase capacity. So if it hurts, stop doing it. Here's the DC side workload. This is an example of what you would see in the sections you would see in the HTML report. And go quickly here. Primarily what we're concerned with is when we look at these, in most cases it's in the LDAP section, in the search and bind. It'll show the top 25 most expensive searches. It shows you the index that was used, the time it took to respond to the search, the client caller, and the search itself. We don't typically see a performance issue with Kerberos. We would see potentially 80 performance issues in the SAM section. That's where your WMI queries, your DS crack name, account operations are done. And also in the LSA section, where we're doing SID to name and name to SID lookups. This is an example of the 1644 event logging. These are the thresholds. We have this deck online. You can download it if you can't read all that. But basically, all you need to do is go to NTDS Diagnostics and NTDS parameters and set. Oh, that's actually wrong. You set the field engineering value, oh, there it is, yeah, 15 field engineering value to a value of 5. We're going to log an event, one event 1644 per search that meets these threshold requirements down there. And so the default thresholds are listed there. The default search time, probably the most interesting one to do, is the search time threshold in milliseconds. And by default, if a search is greater than 30 seconds, we'll log an event. So you would reduce that down to whatever your SLA is, like so maybe 50 milliseconds or 100 milliseconds. And then we would log every single event, one event per search, that meets that criteria. And here's an example of one of those events. And it shows us at the top the client IP. It shows us where we searched, what the filter was, how many entries in the database we had to visit. This one had to visit 319,750 in order to return just 46. You want those numbers as close together as possible. Hopefully, it looks up one entry and returns one entry. That would be efficient. This is inefficient. What index did it use? It used the DNT index, which means it looked at every single row of the database. Why did it have to do that? Well, because the attributes preventing optimization at the bottom said, this guy was searching for the drink attribute. And so there's no index for that, so it had to find every single row, or look at every single row. You see the user account that called the search, and you see how long it took the search, how long the search took. So almost 7 seconds. And that helps you. Basically, when I get these cases, I just enable this field engineering to 5 right away. I reduce that search time threshold lower. That's causing a lot of 1644 events. It's hard to analyze, just by one event per search. So we wrote a script that will help analyze this, the PowerShell script. What it does is, you enable this, you collect those 1644 events, you export that event log, you run the PowerShell script, it imports it into an Excel and creates pivot tables, and we'll show you all kinds of cool stuff, like who is the top client? This IP address did 10,000 searches. He's doing 57% of the searches, so that'd be a good one to investigate. We also have top time per IP as well. And so this guy's responsible for that 1,814,000 milliseconds worth of DC time. So it's very easy to just enable this logging, let it collect some events, run the PowerShell against it. Then you can easily just click in here and see this. It's already, all the color coding is done for you. It's already sorted for you. It's a free download. We link to it in this deck. I've helped customers. It used to take me 2 or 3 hours just to get this info. Now it takes me minutes, and now I'll just go, hey, by the way, have you ever seen this? I'll tell a customer, and within 15 minutes, he's identified some bad actors on his network, really causing some issues. So what are the common issues? CPU, LDAP searches versus ATQ threads. Like I said, I'm kind of harping on LDAP, but those searches that take 6 seconds or 30 seconds or 2 minutes, they tie up one ATQ thread per search. That's a finite resource on a DC. By default, you have four ATQ threads per core. So if all you had was one core, that's not realistic, but if all you had was one core, if 4 searches came in and it took 30 seconds per search, anything else that comes in at that point is going to be sit there and queued up. So anytime you see in this report, this is from the AD Diagnostic Data Collector Set, where it says ATQ threads LDAP and total is the same number, that means we're maxing out and using up all our ATQ threads. And then you start to see request queuing, and how long queued requests are taken to be serviced. So if an application needs an incident response and it's have to wait, is the application, is it resilient enough to wait, or is it just going to crash? or are your users just not able to do anything? And if that keeps building, which it likely does, eventually, nothing's going to work on the domain controller. The SAM call, SAM enum users, that's in the SAM section. Under processes, you see 179 seconds per second. All I did was dig in here, and it shows me what it was doing. LSAS was pegged. I clicked on that, and it showed me everything LSAS was doing, and it was doing this call. I mentioned the slow domain lookups. Run out of time, so I'll skip that, but I do have write-ups on that in the references section. Once you enable the LSP logging, that's what you're looking for. Basically, requests for null / username, no domain specified. And with that, I'll turn it over to Bob.
All right. Thanks, Justin.
Thank you.
Everybody awake? All right. Okay. I am going to make sure that we leave time for questions, so I might skip a couple slides, but I can definitely talk to you after them. Like I said, I'm Bob. My team builds engineering systems for the Office 365 and Exchange Online organization. And to give you an idea of the scale difference, there's about 1,500 people contributing to the Exchange Online / Office 365 product, and my team has about 15 engineers. And so our strategy is build systems that can process all the data quickly to do some of the stuff similar to what Nasir and Justin are doing, as well as help all the rest of those 1,500 engineers not constantly make mistakes that we have to go back and fix. So I'll start off, I'll talk a little bit about just the cloud and our scale. As far as I know, I have to say as far as I know because no one's corrected me yet. There could be some sort of Bond villain with hundreds of thousands of servers in a volcano somewhere that I don't know about, but as far as I know, we have the largest deployment of Exchange on the planet. It is hundreds of thousands of servers, around 240 plus thousand right now, and hosted across hundreds of DCs across the globe. We've got millions of users in hundreds of countries that every day are generating billions of requests. And our growth's off the charts. I mean, we're growing across almost every dimension you can think of. We're growing users, requests, servers, processes on those servers, how many builds we try and ship out to production a day. This chart on the right shows when Exchange Online got serious about this space, or Exchange got serious about the online space around 2012-13, out to last month, essentially. That's our growth in the number of servers worldwide we have. So definitely an exponential increase there. And my team's mission is, we have a tough mission. Our mission is to continuously decrease costs and reduce latency, all while not slowing that growth down, while also not creating SLA problems for our customers, essentially. And so I'll talk a little bit about how that works. The first key concept here is testing is production, and production is testing. We don't use labs, we don't do test passes. We kicked those out around 3 years ago. We found that our cadence of rolling out deployments to production, we're exceeding our ability to even do a test pass anyway. It takes order months to do a full scalability test pass, find fix cycle, and we were shipping, we went from quarterly to monthly to weekly to daily, so there's no, there's no time to do it. It costs too much. If you really want to do a full scale production test, you got to have something that's close to production, and we'd rather put our resources towards actual production. And then the more important piece, I think, was our lab testing was finding issues that weren't in production. They were finding issues with the lab or with the simulation tools, but more importantly, they weren't finding the ones we did hit in production. So we changed our strategy, and instead of doing that, we're leveraging our massive scale that we have to actually do our testing with our users. And this diagram on the right shows, it's the artist's conception of these rings of deployment that we have. And the idea of our rings of deployment are exposure control. And so, a feature crew will be building their build. They'll get it working functionally in ring 0, then they'll check it in, it'll go to ring 1. Ring 1 is our team. It's about 3,000 users in Microsoft, in the Office 365 org, across the planet, across our remote sites and in Redmond. And all of our, my mailbox is in ring 1. All my documents, all my team's documents are in there. And so, we notice when things go wrong there. If things go well there, then it goes to ring 2. That's all of Microsoft. That's Satya's mailbox is in that one, and all of our VPs and things like that. If that goes well, that's the first time we go out to a larger, we call it a slice of production, essentially, outside within our customers. And if that goes well, then we blast it out to all of production. We roll multiple builds a day into production. Now, it's usually about a week plus that we can go worldwide, but every day, at least ring 1 is getting 3 builds a day, ring 2 is getting 2 builds, essentially. And as we're doing that, we've built some systems just because to keep up with that scale. We built some systems that can analyze data and halt on things that are egregious and let things go that are perf issues that are a little lower impact, but get all the data back to our engineers so they can fix them before they get out to production. And we've been doing this for a couple of years, and the real user traffic in each of these rings, it's found like all manner, anything you can think of, and I'm sure a lot of the stuff you guys have seen as well. Latency problems, timeouts, crash fests, concurrency issues with CPU, memory leaks, memory misuse, I/O abuse, disk leaks, bug checks, everything. We see all manner of those things coming up. Okay, so how do we keep on top of that? So basically, we've built a system of kind of fabric and applications on top of that fabric that give us these like 3 capabilities. So the first one is that we prevent the most egregious performance regressions or cost increases, if you will, from even getting out to production. There's some smaller ones that are going to get further, and we have a system that we've built that's intended to contain the impact. And so think of it as like putting, the bomb's going to explode, so you put the bomb in a box, it'll blow up the box, but it won't hit everything else. And then these systems give us data that we use to constantly analyze and optimize. And our team jokingly calls it finding change in the couch. Like we got to pay for some new features, so we're going to go optimize and find some more resources. And the big X's on here on the right think of that as impact from performance issues that the customers in that ring feel. So ring 1, we feel a lot. My mailbox is off a lot, but that's a price I'm willing to pay because we're finding performance issues, we're finding issues that we fix before our customers see it. And the systems that we're producing, they're literally processing petabytes of data a day. And they're helping us find these issues in the rings as well as do this ongoing optimization. I do it time. Okay, I'm going to skip this one. This is essentially, we have a set of platforms that we use to build apps. I'm just going to talk about the apps. I can come back to this if we have time afterwards. So we have basically 3 flavors of applications that we deploy and use. So the first one is, I talked a little bit about this idea of containing things. So we have a system called PUMA, which is Process Utilization Management and Accounting. Super geeky. Basically what that does is it uses Windows job objects plus those platforms that I talked about they're on the last slide, to enforce hard caps and soft caps. So we can say, okay, these processes will never get to use over a certain amount of CPU, a certain amount of memory, a certain amount of disk, and we're adding network. And then we have this idea of soft caps where they can use whatever they want until the machine is under duress. Like if we say it's 95% CPU or higher, then we'll push it down and push those processes down to prearranged configurations. We have this idea of smart alerting when components are getting close to those thresholds. So rather than kind of letting them hit and get pushed down, we will gather the forensics data on what's happening and why we're hitting those thresholds, and basically escalate to the on-call engineer for that area, and they'll start working on it to fix it. And the last one around stability here is we have a tool called Measure Performance, and Measure Performance lets an on-call engineer across that 1,500 that I was talking about go into production, and they can get a kind of top-down view and zoom in on, okay, how does a DAG look? Where are the hot spots? If I zoom into, it'll show it like, oh, there's a specific machine. In this case, it's this 509 machine that's hot on CPU. They can zoom in, they can see what are the stats of that machine, how does it look? It's got stuff highlighted in red and yellow to give the engineers a quick spot check. And then it actually shows what processes are causing it. And we use that to kind of triangulate what issues are happening. We also have these applications that are around efficiency. The first one is this idea of the call stack viewer and the cost on the left, which we can use to find the most costly call stacks across the entire fleet of machines. And so we have a couple folks they're on a team called the Scale Brigade, and the Scale Brigade essentially just every day comes in, gets their coffee, fires up call stack viewer, sorts on most expensive CPU call stacks, and goes to town on trying to optimize those. And we make a lot of progress there. That's that find the change in the couch thing that I was talking about. But then, because we know there's only 15 of them and 1,500 engineers that every day are writing code that could also cause problems. We've take a subset of this data and we make it available at design time in Visual Studio for the developers, and they get a warning like you're in the most expensive code in production. Here's some tips and tricks to avoid making kind of silly perf problems. And the last one we have similar sets of stuff for latency. That first one was around efficiency and kind of server-side resources. And so those tools allow us to do and create layer cakes that tell us, we call them layer cakes, that tell us, okay, this API or this request is taking about 750 milliseconds total, and here's how it breaks down. The blue is the store time, the yellow is the network time, and that allows us to kind of know where we can focus our time. And then on the right is, again, like the call stack viewer I showed you on the previous slide, except it's for latency. So this allows like a perf brigade set of folks to go and say, okay, I'm gonna find the slowest calls in production, like the 99th percentile, what is the slowest, and go kind of start pushing those down. Okay, so you're probably saying, so what? That sounds neat, but how does it help me in on-prem? And there's one thing you should know first is, if you don't know, cloud and on-prem share the same build. It's the exact same build system, it's the exact same build, it's the same set of developers building it. And so anytime we make fixes, it goes into the same build that the on-prem product is made out of. And so you're getting everything, some of the stuff that we talked about earlier actually started out as issues in the service that we fixed and then pushed into on-prem. And then the other one, I have a star by it because where you share the same OS or the same configurations that we have in production, or SKU configurations, you're also getting that benefit as well. So we're finding issues in our underpinnings and our dependencies. We're finding issues with, as we go up higher cores and higher memory. And as we fix those issues, they accrue back to on-prem because of the same build. There's kind of 4 ways these manifest themselves. First is, like I was saying, there's just fixes to exchange. So like CPU memory, we've made, like this year to date, we've saved about 2 cores of CPU, basically, during our processing time with fixes. And we've saved about, I think, with memory optimizations, we've saved about 10 gigs of RAM. Now, that doesn't translate immediately into suddenly on-prem can reduce how much resources it has, because generally we use that, we stick new features in on top of that. Like I said, we also push fixes into our dependencies. So in Windows, for example, Windows 2016 and Windows 2012, there is a fix that's being made for IIS queuing that actually reduces all of our protocols by 150 milliseconds. So we have like a private of that in production right now, but once we have that ready, then that'll be something that can be applied to on-prem as well. Or CLR, we drive a lot of kind of optimization cycles with them to go fix deadlocks we find or fix kind of performance issues that we see with that, because as we said earlier, we're almost all managed for the service. The third point is we actually do work features just for performance. So an example of this was announced earlier in the week. If you caught the Inside Exchange talk or the storage talk, we're coming out with a feature where we can do, if you have SSDs, you can do meta info caching on SSDs, so you get super fast, like you're serving some of your requests from flash versus from spinning disks. Or there's also talk about Big Funnel, which is Bing's search coming in. There's a bunch of features we get, but it also is a lower latency search that we'll get. And the last one is this idea of advice on the recommended hardware and software configs with Jeff's team and other folks, where as we start to scale up, and we're starting to scale up the service to more cores and more memory, we're finding the right sweet spot for that, and that kind of shows up back as on-prem guidance for you guys as well. I got through that pretty quick. That's all I had. I think we're going to do questions now. So if you guys want to do questions, come to the mics. That would be great. I think that's Q&A.
When troubleshooting Exchange Server performance for the event log, you said one of the first things you do.
Yep.
What do you usually set the event log level at? Like the set event log level commandlet? Should we start at the lowest or medium or what?
Just leave it with the default. So the default one is capture pretty much all the information. One other thing that I just want to go what Bob has said earlier, there's plenty of logging that Exchange create by default. If you look under the log subdirectory on the Exchange installation, you'll find that there are logs associated with each of those components. So if you're looking, for example, ActiveSync or or issues with some particular component, you can look into the specific logs over there. So I will leave it as default to start with, but generally capture all the information that we need.
Okay, thanks.
Right, so for Justin, when you go with the, set off the 1644 collection and you come up with an offending box, what at that point would you do? I mean, assuming this is an ADR, you would have to find the application that's doing a lot of the
Right.
searches, generating all that search. I mean, generally, you can't just blow away that box and start again. You'd have to find what it is that's,
Right.
that's taking up the...
So that's why we once we identify the clients, we run netstat minus ANOV to see basically what active connections are there and what process ID is using those connections. And then we use task list SVC, /SVC, to tie the process ID to the service name. And then now we know the offending service or application or script or whatever. And then what we do from there just depends on what we can do.
Thank you.
This question is to Mr. Nasser.
Yep.
Regarding the health script, you said it gets updated with every CU. Is it also backward compatible? And would there be any issues to expect if we're running it with a backward?
So you can run it on, on 2013. Even you can run it on 2010. I have not tested it lately, but you can run it on 2013, 2016, and you can run it. It doesn't matter which CU you are because it is looking for all of those different CUs that you have, you know. So it is backward compatible with previous CUs that you have. And that's the idea. If you are running on a CU, say for example, CU1, and now we are on CU7, that's almost 18 months of time passed between, you know, those, and a lot of fixes. So it will give you a red line that will tell you are behind on your CU. This is the latest CU, and go from there.
Thank you.
Yeah, you're welcome.
You mentioned at the beginning of the session also to load balance the mailboxes across the databases. So what guidance do you have here? Because right now it's really hard to figure out, for example, where are really heavy users, because a mailbox size or an item count is not really a kind of trigger for that.
Yeah, we don't have a fantastic solution for that, and going by size and item count is generally going to be what you have available that you can script against. Beyond that, it's going to be manual tuning for the most part. So yeah.
How are you doing this in Exchange Online?
Do you want to get into that?
Sorry, I missed the first part.
How do we
Balance
load balance databases for performance, load balance mailboxes across databases for perf and
We have
Exchange Online?
a multi-metric load balancing system that's looking at lots of different resources and deciding the best place to look.
Yeah, it's extremely complex, and we talked a little bit this week about how it's even more complex now, where we're actually looking at where users' requests are coming in and trying to relocate based on that. But
I mean, it's a good question. Like, we did talk in the Inside Exchange discussion that Matt Gossage and Anop did. Like, they spent 2 or 3 slides explaining how that system works, and it is fairly complex, but yeah.
Last question. In Exchange Online, you have, for example, also a default limit with 100 gigabyte, for example, for quotas for deleted items, which currently the customer needs to take care of, because I thought also in the beginning, okay, Microsoft will automatically, for example, increase those limit. Are there any kind of plans to change this kind of behavior, or is really the customer is needing to take care of? Because I already had a couple of incidents like that.
Increasing the size of the mailbox quota from
Yes.
50 gig to 100 gig,
Yeah.
that's automatic. You want to find out if there is any plan to give you advance notice that
Yeah.
it's going to change.
Oh, I see. I don't know the answer to that, but it's something we could follow up on, I guess.
Would be really helpful, yeah.
I mean, there was a discussion earlier in the week on change management and like notifications of changes, and that's probably the best. I would say, I would check that talk out. That's the recording. And that's where all of those notifications should come. In that discussion, I'm pretty sure Mike Ziak said,
Jeff Kissinger.
we're not perfect, and sometimes we miss it, but that's where it should come through, essentially.
Okay.
I suspect those guys are about to cut off our mics because we're 4 minutes over. I know there's a couple more questions, so feel free to come up and we can talk to them for a few minutes up here. Thanks everybody for coming. Appreciate it.
Thank you.